gravitational force is determined by the mass of the two objects which have a gravitational force acting on each other and by the radius between them. So the equation for gravitational force is the gravitational constant times the first mass times the second divided by the radius squared. This plays a part in the velocity needed to orbit one of the objects if you're looking at the other object. Because if the gravitational potential force is greater, you're going to need a higher speed to be able to orbit it and not collide into it. So let's look at an example problem from the AP test which shows this mathematically. So two satellites of masses m1 and m2 orbit a planet of mass m in circular orbits. The satellites travel in opposite directions with speed v1 and v2, as shown in the figure above. Their orbital radii are r1 and r2, respectively. Assume that m is greater than m2, which is greater than m1. So this is a diagram of what's going on. And our question here is asking what the ratio of the speeds v1 over v2 is, and it's question 24 of the AP exam. So to find this, let's start with centripetal acceleration. So centripetal acceleration is equal to v squared over r. And let's also set up our equation for the gravitational force for the first object. So F1 g equals g m m1 over r1 squared, like this. So if we start with these two equations, we can determine that the centripetal acceleration, or this acceleration of the first object, so we'll call this A1, is equal to g m, big M, over r1 squared. So because we applied them to each other and figured this out. And then we can keep going and say that v1 squared equals r over r1, sorry, not equals r1, is the acceleration of this object. So we have this ratio. That's the centripetal acceleration of this object in relation to the other constants of this problem, like the velocities. So from there, we can find v1 squared by isolating it. So v1 squared is equal to g, that being the gravitational constant, m over r. And we did that by multiplying r1, sorry. We did that by taking these two and multiplying both sides by r1, so it canceled out on the side with the v1 squared. And then if we square root this, we'll get what v1 is. And that's equal to gm, or the square root of this whole thing, gm, over r1. So we have v1 by doing that. And it'll be a lot quicker to find v2 because we can just use what we found for v1, replacing r1 with r2, because the rest should just be the same, because those are the same constants for both. So we know that v2 is equal to square root of GM over R2. So now we need the ratio of V1 to V2. So we can do that by just using these formulas we just found. V1 over V2 is equal to square root GM over R1 over square root GM over R2. You can't really see this because it's kind of small now, but that's pretty much what it would be. And then the GMs cancel out, and what we're left with is the square root of R2 over the square root of R1, just like this. And that is the ratio of V1 over V2. And that would be option A on the AP test multiple.